Constructors. When a function is used as a constructor with a new keyword, its this is bound to the new object being constructed. No matter which object the constructor function is accessed on, the value of the keyword this becomes the value of the new expression unless the constructor returns another non-primitive value. So here we have an example. We have the function name uppercase letter C, and inside of the curly braces we're gonna use the keyword this. We're gonna use the dot operator, so we're gonna have this dot a, and we are gonna assign it to the number 37. We close the curly braces of the function uppercase letter C, and now we're gonna have a let declaration, and this variable is gonna be named O, and it's gonna be assigned to the new function uppercase letter C. So we end up this statement with a semicolon, and now we're gonna cancel that log the variable O dot A. So the result that we are gonna get is gonna be the value 30, the number 37, because right now the variable O is being assigned to the new function uppercase letter C. So below we have the function uppercase letter C2. This is another function. Inside of the curly braces, again, we're gonna use the keyword this dot a, and we're gonna assign it to the number 37. We end up with a semicolon, and now we're gonna return an object with the property a, and its value is gonna be the number 38. We close the curly braces of the object. We close the curly braces of the function uppercase letter C2, and now the variable O, the variable that we declare with the let declaration, is gonna be assigned to the new function uppercase letter C2. So we end up with a semicolon, and now we're gonna cancel that log O, and O, again, O is the variable here, and we're gonna cancel that log O dot A. So the result that we're gonna get is not gonna be 37, because what we are gonna get is the property of the property that is in the function C2, but we are getting it as a return, and when we return it, the value of the property A is going to be 38, not 37. So we can grab this example, and we can go to any tab. You just press Ctrl+Shift+I to open the Chrome tools. We paste it, and okay, identifier C has already been declared. Let me check. Okay, so I go here, clean it up, paste it, and there you have it. So yeah, we're gonna get the results, the numbers 37 and then 38. Again, let's do it again. So we have the function uppercase letter C, and inside of the curly braces we have the keyword this dot A that is assigned to the number 37. So outside of that we have the let declaration. We have the variable O that is assigned to the new function uppercase letter C. So now we're gonna cancel that log, the variable O dot A. So the result that we are gonna get is the number 37, and that is the result that we get here. So outside of that we have another function, the function uppercase C2. So inside of the curly braces we're gonna have the this dot A that is gonna be assigned to the number 37. We end up with a semicolon, but now we're gonna return an object with its property A and its value 38. So outside of that, the variable O that we declare with a let, the variable O is gonna be assigned to a new function, and this function is gonna be uppercase letter C2. So when we cancel that log, the variable O dot A, the result that we are gonna get is gonna be the value of the property A that in this case is going to be 38. So that is that for this example. Here in the second example, uppercase letter C2, because an object was returned during construction, the new object that the keyword this was bound to gets discarded. This essentially makes the statement this that A is assigned to the number 37 dead code. It's not exactly dead because it gets executed, but it can be eliminated with no outside effects. Now we have super. When a function is invoked in the super.method form, the keyword this inside the method function is the same value as the keyword this value around the super method call, and is generally not equal to the object that super refers to. This is because super.method is not an object member access like the ones above. It's a special syntax with different binding rules. For examples, you can check out this link, super reference. Now we have class context. A class can be split into two contexts, static and instance. Constructors, methods, and instance field initializers, public or private, belong to the instance context. Static methods, static field initializers, and static initialization blocks belong to the static context. The keyword this value is different in each context. Class constructors are always called with the keyword new, so their behavior is the same as function constructors. The keyword this value is the new instance being created. Class methods behave like methods and object literals. The keyword this value is the object that the method was accessed on. If the method is not transferred to another object, the keyword this is generally an instance of the class. Static methods are not properties of the keyword this, they are properties of the class itself. Therefore, they are generally accessed on the class, and the keyword this is the value of the class or a subclass. Static initialization blocks are also evaluated with the keyword this set to the current class. Field initializers are also evaluated in the context of the class. Instant fields are evaluated with the keyword this set to the instance being constructed. Static fields are evaluated with the keyword this set to the current class. This is why arrow functions and field initializers are bound to the class. And we have this example here. We have a class, uppercase letter C, and inside of the curly braces we have the instance field, and it's assigned to the keyword this. We end up with a semicolon, and now we're going to have the static field, and then again it's going to be assigned to the keyword this. We close the curly braces of the class uppercase letter C, and now we have the constant declaration name lowercase letter c that is assigned to the new class uppercase letter C, and we end up with a semicolon. So now we're gonna cancel that log, and we're gonna use the constant lowercase letter c that instance field, and we want to see if it's equal to the constant lowercase letter c. So pretty much we want to see if it's gonna get us a boolean true or false. So we're gonna get cancel that log, see that instant field is equal to c, and the result is gonna be the boolean true, since the constant lowercase letter c, that instance field is assigned to the keyword this and is equal to the constant c that is assigned to the new class uppercase letter C. So in the next line we're gonna cancel that log uppercase letter C that static field. So and again, that static field that is assigned to the keyword this, and we want to see if it's equal to the uppercase letter C, and then again we're gonna get the result a boolean true. and we can check out in the current developer tools. So I press enter. Syntax identifier has been already declared, so I have to refresh it again or just open another tab. So okay, and there you have it. We have the result, two booleans, that is going to be true and true. But what will happen if we have cancelled that log, the constant lowercase letter c, that instant field is equal to uppercase letter c? What will happen? We wouldn't get a true, we will get a false. There you have a false, a boolean false, and then you have a boolean true. But we can also check out the second example. So we have the cancel.log, uppercase letter c, that static field that is assigned to the keyword this is equal to the uppercase letter c. But what will happen if instead of uppercase letter c we just type in lowercase letter c, and the result is gonna be false? So instead of having two boolean true, we're gonna have two booleans false. So I press enter, and there you have it. The result will be false. So I'm just gonna make it correct. So cancel.log, uppercase letter c, that static field is equal to the uppercase letter c, and cancel.log, lowercase letter c, that instance field is equal to the lowercase letter c, that is pretty much the constant. So we're gonna get true in both cases, and there you have it.